Good afternoon, everyone. Can you hear me at the back? All right, cool. Thank you. So, good afternoon, and thank you all for coming. So the next 50 minutes or so, I'll be talking about enterprise messaging security and how this is an overlooked aspect in today's world, and we need to really focus on the security of enterprise messaging applications, which have been ignored so far. So I'm Gursev. I'll be driving this presentation for the hour or so we have. So the agenda is, how many of here have worked with enterprise messaging applications, JMS or something on those lines? Wow, that's a good number. So the messaging 101 is there to make sure that people understand what enterprise messaging is. Not a lot of people know about it. And then I wrote a tool called JMS Digger that will help you assess enterprise messaging applications. Currently, it targets ActiveMQ. It's written specifically for that, but the code is generic JMS code. It's not ActiveMQ specific until for a few places which specifically target ActiveMQ only. And then we will look at ActiveMQ case studies and some vulnerabilities that I found and some vulnerabilities others have reported. So when I submitted the paper, there were like few vulnerabilities that I had identified which were not known. So they were 0 days at that point of time, but now they have been fixed. So you would not really see 0 days in this presentation, maybe the next one. So then we will look at some techniques which you can do to attack messaging applications, and all along the presentations we will have several demonstrations after the messaging 101 phase. So let's go ahead and get started. So I'm Gursev. I work with McAfee's functional practice as a senior principal. I've written several tools. I wear multiple hats at my organization. I deal with Java security, web application security, mobile, and more stuff. And then my research work has been voted amongst top 10 web hacking techniques by the community in 2011, 2012. My contact details are provided here if you wish to contact me regarding this. So messaging 101, so enterprise messaging. What do you see? It's not that. So most of the people, if I say that the topic is going to be enterprise messaging, they talk about Microsoft Communicator, or maybe they say I use Skype for my enterprise messaging. So how is this different from that? So it is not that. So I just wanted to make that clear upfront because this is a confusion that everybody has. So enterprise messaging, so what it really is, it enables different types of organizations with heterogeneous systems to talk to each other via messages. So that is all it is about. So you have like one .NET technology stack, Java stack. It's asynchronous because you really don't have blocking that needs, and it provides very high amount of scalability. So you submit a request, you disconnect, and you wait for the response. Either you poll or the response comes back to you. So it is extremely scalable and very high reliability oriented, and it's asynchronous, and so it's not a web service. But I have seen people who use enterprise messaging to send out SOAP messages and do other type of HTTP stuff. So I've seen people encapsulating HTTP in enterprise messaging. So I mean, weird use scenarios, but they exist there. Now, and it forms a transaction backbone for a very large number of financial organizations. So why are we discussing about enterprise messaging security? So one of my friends, he works with a company, and they deal with a lot with enterprise messaging. And I was discussing with him one day, and out of curiosity, I asked him, how do you guys secure your stuff? And he looked at me, and it was a blank stare. He says, what do you mean by security? We are inside the firewall, the typical response we get, and the systems are legacy, like 5 years, 10 years. So they haven't really looked at the code, what it does, how it is configured. So I got an idea, maybe I should take a look at that, and that's from where I started this work. This is how a typical enterprise messaging application looks like. You have a client, and you have multiple clients which exchange messages over the message broker. So the message broker can provide a queue or a topic to exchange messages, and the core is the message broker, and you have clients which exchange messages via the enterprise messaging broker. So that is what it is in the simplified form. Now, what is a message? It's an object. It's a JMS object which will transfer data between JMS clients. So for this presentation, I'm specifically looking at JMS-based applications, not the other type of enterprise messaging applications. So it has headers, and properties and a body, which every message should have. These headers play a very critical role to send the message from one source to destination, and henceforth. These messages may contain personally identifiable information, business critical information, and other stuff. So they are something which are of value. So if I am going after an enterprise messaging application, I probably would want to get hold of the messages that are flowing between the enterprise. Let's say Citibank and Visa are talking to each other, right? So if there is a financial transaction flow that is happening between them and I can tap into few of those, I know what's going where, and I can get some competitive edge over there, or maybe get some sensitive information out of those. So type of messages. So there are like several type of messages. I have like provided only the ones that are specific to JMS. Different message brokers would extend the API for their, like, to provide different type of messages, but here we are focusing only on JMS messages. So 6 type of messages in general. The message is a pure message which is just for signaling purpose. Then we have text message, which is used to send strings. So this is where I have seen people using it for SOAP and HTTP-based web services or other things. And then you have stream message, in which you can embed like raw data types, integer, float, and all that. And object message, byte message, and map message are 3 more categories of messages. So why I'm introducing the messages? Because the JMS Digger tool, which we are going to talk about, if it intercepts the message stream, it will parse the messages and display them and categorize them as per the type of message you have. So it's easy for you to really get to what you want to see. Very important concept is of queues and topics. So the queues, what they allow you to do is first in, first out. So one message comes in, it goes out, and one message is delivered only once, right? So there is one receiver, one sender. There may be multiple receivers, but the behavior is not defined in JMS specification, which is JSR 914. So that is about queues. And topics is, I send a message to a topic, and that message is sent to all the subscribers. So there are 2 different ways of expressing it. So queues have sender and receiver. In the topics, it is publisher and subscriber. So any number of subscribers can subscribe to a particular topic. It's like a radio. And queues are like a typical queue, first in and first out. Message broker forms the core of the enterprise messaging. So this runs the show. The client sends the messages, but it is this guy which is the center at the heart of the things that runs the show here. So it allows message routing, message transformation, and it hosts JMS destinations. So that is very important aspect, that only the message broker should be allowed to create or host the JMS destinations. Let's say if I'm a client, as per the JSR specification, I should not be able to create new destinations on the broker. But as we will see, things are different with ActiveMQ. Different types of few example message brokers are ActiveMQ, WebSphere-MQ, RabbitMQ, and almost all the message brokers I have seen so far, they support JMS API, and hence I use that to write the tool, which you guys can use if you are assessing an enterprise messaging application. So it's a general purpose API which provides a consistent interface across different products. So you write it once, use it everywhere. On the other side, you support an attack tool. You write once, you attack everywhere, right? So if you know that the authentication is going to work, if I create this program and I can load up any jar file for any other message broker, I can attack its authentication scheme. So you write that code, you run it everywhere. The underlying protocol really does not matter here. So the broker jar will help you translate into your underlying protocol. And that's why JMS Digger was written using JMS API. Just to revisit that, so this is what we discussed. There are clients which communicate messages via the broker, and inside the broker there are queues and topics to which the messages are sent. And how attacker looks at it, everything in this entire change may be of value. So if you are able to compromise the communication mechanism, you get all the messages. If you compromise the broker, you get everything there. If you compromise the client, you can get something that is specific to the client and something of value that lives there. So why bother? As I said earlier, enterprise messaging has not been explored in terms of security at all. A lot, a significant amount rides on it. So a business reputation and whatnot. So it's time we look at it. So let's look at the tool. Just a couple of screenshots before we go to the demos. So this is how the tool looks like. The version is 0.110, but it really packs some good amount of functionality for enterprise messaging assessment plus something specific for ActiveMQ. So it provides you the ability to test authentication or even do credential brute force, as I talked a while back. It can allow you to put hooks into the message broker, retrieve the messages from there, dump it on your local file system, and it will pass the messages out with all the properties, what that property has, what type of property it was. So it will like categorize the messages as per the types of the message, and it will allows you to manipulate durable subscribers. For the folks who have worked with enterprise messaging, they would be aware of what a durable subscriber is. So I would not go into more details on that. Otherwise, everybody would just run out. And there are ActiveMQ specific operations here that this tool provides. So we will look at those in the demonstration. So these things are very specific to ActiveMQ and the way the ActiveMQ works, how it encrypts credentials if you want it to store for you. And there are more things that you can do with this tool. And it's open source. The source is available. So far, I can say I have done 11 commits, and it's I continue to I plan to continue and working on this tool so that it's more useful and more. It supports more message brokers, and that's the URL where it is available. Okay, so let's go to ActiveMQ. I chose ActiveMQ because it's an open source message broker, and I can really go through the source, see what's happening, where is happening, and the documentation. There were books available on it which I could go through, and I could relate with JSR 914, which is a specification, and see how the security is done. So that was my choice. So one of the first things you will notice about ActiveMQ is the number of protocols it supports. These are 8 protocols right there, and we know that writing one protocol right is hard, and this product is supporting 8 protocols. Kind of attack surface you have is unimaginable. Now start breaking down the components it has. It uses Spring, it uses JavaScript, and several other components, and they all use different technologies. The attack surface, a product like this is extreme. So I've just looked at a couple of these things. I've looked at HTTP, and I have done the JMS part, which is the open wire here. So not the protocol, but using JMS, I have leveraged on open wire to talk to the JMS, talk to ActiveMQ here. So that will be my focus, but you can imagine with so much of just the protocol attack surface, things can get very difficult to make it secure. So ActiveMQ exposes a web admin interface, right? Everybody wants to give an admin interface over web so that it's easy for somebody to manage. And what it allows you to do is, it allows you to create and delete destinations, which is the topics and queues, which the JMS specification says should be only done by the broker, which is the right thing to do. But this web admin interface was unprotected. So if I knew that that box on my organization, I'm a developer and I knew that that production box, or I'm somebody in the QA team, I know that that production box hosts ActiveMQ, I can just connect to the port on which it is running because it is unprotected. There is no credentials to it till release 5.8.0. And the kind of things I can do is I can delete any destination, message, queues, or I can read messages out of that, which may be production and sensitive, and you would really not want to have everybody or admin team to have access to that. It listens on 0.0.0.0. So can anybody tell what impact does that have when something listens on 0.0.0.0? All interfaces, right? So that's dangerous. So that allows ActiveMQ, if you're running it on your perimeter, the interface is open to the entire internet. So I found instances where the production system's admin interface, which was unprotected, living on the internet. And these are just a few. I'll just show you 2 screenshots. Here you can see that the Stomp protocol is being used. These guys are using Stomp protocol. There was no WebSocket. There was no open wire. So this was a Storm protocol, and this was open on the internet. And I like contacted the guys, and they just brought it down immediately because it was a production and business critical message broker ActiveMQ, which was running open on the internet. And if I could connect to it, I was able to. I mean, I could have deleted their queues and caused a lot of problems with their infrastructure. And then this was another instance. So here you can see these are the queues which are running here, and a couple of them had outstanding messages. So I could really connect to those, and we will see in the next slide. Now, since the web interface is listening over 0000, it was easy for me to do a quick find with Google or Bing or whatever to identify some hosts which have a particular URL, right? I just did in URL and identified that these hosts have web admin exposed. Now, the next step was, well, the default port is 61616, as you see here. Here, you see the default port on which ActiveMQ listens for OpenWire is 61616. So I tried to connect to those, and the port was open. And it was a production server, and I tried to connect to it with default credentials, and the messages which were going through some of the queues could be downloaded onto my local system, which was when the organization was really surprised that that type of information could be taken out that easily. So it's critical we secure them. If we don't do it, well, this is what happens. So a typical XSS. So this was interesting because the type of attack vectors that need to go here. So there was a scheduler functionality in ActiveMQ which allowed you to schedule messages. So if I schedule a message for a particular cron, I provide a cron string and here this is the cron string and the message. So that cron string would be interpreted and the messages would be sent as per the cron string. But when I looked at its code, what it was doing was, if the cron string starts with 5 zeros, it will accept that as a valid cron string and store it into the database. So once I did that, the scripts will get in, and you can like do the cross-site scripting and other attacks. And since this was unprotected, using this I can leverage and go inside their network and potentially do port scanning and other things, right? I can upload other type of vectors which would then be injected into somebody else's environment. So the impacts were like that can be done on somebody's network with this persistent cross-site scripting is very dangerous. This is another cross-site scripting on their some demo application they have with it. Won't spend time on it. There are better things at the end. So there are a couple of more CVEs which deserve a mention here. So in 2012, 6551, somebody was able to do a denial of service just by sending HTTP request to ActiveMQ server. And then, as usual, the crypto SSL was not done right. So they were not verifying the common name against the server IP address or the server name. So that lead to man in the middle. So if I knew that these guys are securing their ActiveMQ with SSL, but I can still do a man in the middle by routing the traffic around. So that was like, again, a dangerous one. Now, coming back to ActiveMQ again. So ActiveMQ provides you with the facility to encrypt the passwords before you store them onto the local system for authentication. So the password storage works with password based encryption. So what you do is you provide your password and you provide the key. So this is another password that you type in and it gets encrypted and you're able to get encrypted password. Now when you want to authenticate to ActiveMQ, you would provide your password and the ActiveMQ server would have this key with itself and it will decrypt that encrypted password using this key and it will match the two. So it's not hashed, it's encrypted, which is wrong thing to do, right? I mean, you're encrypting passwords, this is not right. Now, what can we do? We can, if you're an internal pen test or you get a configuration file of ActiveMQ server, you can do a password brute force, you can decrypt it. So this JMS Digger tool comes with a feature which would allow you to decrypt passwords. So let's load a couple of them. So these are few tabs here. So it is organized into two type of things. One is the pre-exploitation phase and second is post-exploitation. So pre-exploitation talks about you check the configuration if you're able to connect or not, try to test authentication, and the post-exploitation is if you're able to find some vulnerability like SQL injection or something which allows you to bypass authentication, you can leverage it to download messages and like really get into the exploitation portion of it. So Um, I'm going to try and brute force the password. So these are the encrypted passwords. So this is how ActiveMQ stores the passwords. I extracted the passwords, 3 of them, and stored them in a plain file. And then these are the decryption keys, which would help me decrypt the passwords. All right, so these are the passwords, and I'm going to run the decryption engine against that. You would see it's pretty fast. Now I have the results here. I'll just show that to you. Are you able to read it at the end or here? Is it like visible? If not, I can do this. So you can see that it was able to decrypt the password. So here you see this is the password or the key that was used to encrypt these 2 passwords, and it was then stored in the database. So the speed is pretty good here. I was able to do 1 million password decryption attempts in 240 seconds on a single threaded machine. So the algorithm they used is from JASCYPT encryption library, which attempts to make encryption and decryption easier for you. So you can use that, and if you get your hands on one of the ActiveMQ configuration files, you can pretty much brute force it in a very short amount of time, right? In 1 hour, you can, I don't know, maybe run through 20 million or so, or maybe more. Pardon? So key is like a password to encrypt the password, right? So it is. Yes, you can have your own keys. You can have your, so that's why this brute force functionality allows you to run through, a list of passwords, and it'll check against all of those. Right. So I haven't really done a lot of pen tests on this, but like for the my friends who I said like initially got me going, they have really not done anything like to configure. So and their products is being used by a lot of Fortune 500 companies. So but pretty much it could be like if you get the access to configuration file, you can very much get the passwords out of that. Now the default active MQ configuration, it does not have any authentication, no encryption, and there's more. If you go on and look into the product, there's more. So the authentication schemes. Now we're going to look at the authentication schemes because that's the first defense. Like after you go past the authentication, then that's the time when you start doing other things. Now the default scheme is none. It's like anonymous authentication for FTP. You can just connect to it, download messages, or edit the queues, send messages to the queues to which you are not authorized to. Then there is simple authentication plugin. So simple authentication plugin is the very basic that it provides. You have an XML configuration file, provide ActiveMQ with that, and you're done. And there is JAS-based authentication plugin, which is you write your own authentication scheme. You have a database or an LDAP server at the back end to which ActiveMQ will talk, get the credentials, authenticate you, and do other stuff. So ActiveMQ simple authentication plugin, it does not provide any mechanism for account logout. So if you are using ActiveMQ, you will provide an XML file which looks something like this. It will have simple authentication plugin, users, username, and password in the file. Or you can have it encrypted here, right here. Now the problem is that since you don't have any account logout, and anybody can brute force it, right? So that's the big risk if somebody can brute force. And since middleware is not really considered big risk, people tend to keep weak passwords. As she was asking, like again, talk to my same friends and asked, like, what type of passwords do you have with it? And they were like, no, we don't know whatever was default still lives on. So in that scenario, if you have default username and password for different brokers, you can get in, or you can just brute force that if simple authentication plugin is being used. So let's see a demo in which you can do a credential brute force for ActiveMQ. I'm going to do this authentication tab, and I'm going to load a lot of credentials. I'm going to give usernames, user IDs, and then a lot of passwords. All right. So so this is the configuration here. I'm going to remove this username and password from here. So this is configuration, which is the URL to which JMS Digger should connect to, which is TCP 192.168.127.130, and 61616 is the default port. And I'm going to just say go. It is going to start the attack, and it is going to give me all that detailed stack traces, what are being returned. And for all the correct or valid login attempts, it will give me the username and passwords that worked here. So here, these are the usernames and passwords that work. So none of them is the default one. The default is system and manager. So this is, the username is admin and password is password. Username is guest and password is password, and username is broker and the password is password. So it could run through all of these and give me the username and passwords. So this relies on JMS again. So if you want to use this for your own broker, you can pull out the code, use it for your purpose, and you'll be done with that. Now, after this, so the next step would be looking at JMS and its encryption. So there is no API support, right? So JMS was not supposed to address the crypto concern. So it is like how the broker should talk to, and the transport layer was left to the different brokers. And when you do that, there is no portability. If you write an application at one place, you're going to have to reconfigure the crypto at another install base or whatever you want to take it. So you have to have people who know different brokers. We want to move your application between different brokers. And encryption is certainly it's hard to get it right. Even the broker folks would not able to do right because they were susceptible to a man in the middle. Imagine doing it with different types of brokers. And the information that is available is, I searched for a couple of other brokers. It's not very informative. I mean, you really have to get down and talk to the customer support and try to get that information. So it's not very easy to get hold of as well. So which makes encryption a problem for messaging. And it's important to do, but it's even more important to do it right. So let's go and look at some attacks that we can go through. So I mentioned about JAS-based authentication, right? So you can have the simple message plugin, or you can have JAS-based plugin. So in JAS-based plugin, you will write Java authentication and authorization service by yourself. It will either talk to the database, or it will talk to LDAP server, and it will query that for the credentials. Now, when you're doing that, your application exposes to typical web application flaws like SQL injection, LDAP injection, or other things. If you have an LDAP backend, that will go away again. So let's see a bypass here, and authentication bypass with SQL injection for GMS, which again, most of the folks wouldn't have any information about in the enterprise messaging or middleware domains. So I'm going to give a admin username, and we can see the login failed. Now I'm going to try and give some SQL string. There is a double quote there. Now you see that this thing, there is an, okay, I'll show you that. I'll just show this error message first. So there is one stack trace which says login failure. Is this visible at the back end? Okay, cool. And then it says username or password is invalid. So basically it was invalid. And now I'm going to give a SQL special character, and let's see how it behaves. We see that the stack trace is longer now because of the smaller bar. And if you go back, you see SQL error creates SQL exception, SQL error. If you go up a little bit more, here, you can see that there was a SQL error in here, right? So SQL exception, you have an error in your SQL syntax. Check the manual that corresponds to your MySQL server. Version for the right syntax to use near admin, @line, whatever. So that is a typical SQL injection. It doesn't live only in web applications. It lives everywhere. So the moment you start using the database, you run into this problem if you're not doing the queries right. Now let's try to bypass this and see if it works. One, right? So now my credentials are working. So they used JAS-based authentication, but they didn't do it right. I like for this demonstration, I wrote a JAS plugin for ActiveMQ, which talks to MySQL, and there is a database, of course. So here you are, and you have been able to bypass it. Now what we're going to do is we are going to use this username and password for our demonstration and try to retrieve the messages from the message broker and dump it to our local box. So here, I'll copy this and I'll paste admin and the password here and I'm going to test the configuration so that I'm able to connect it nice. So configuration parameters are okay. Now I can connect to this and I can do stuff that I should not have access to do. Let's take a step ahead. All right, so we are beyond the authentication phase. Now what to do? Now there are multiple ways in which you can do authorization with ActiveMQ. You can do destination-based authorization, or you can do message-based authorization. For this purpose, if you don't do it right, so there are several attack scenarios. For example, if you don't do it right, a user A will be able to access a queue which is just for user B, or a user A will be able to send a message to topic which he should not have access to, right? But here, on the other side, if you have something like SQL injection, it really does not matter if you do your authorization right or not. He can potentially get in as anyone and do anything he wants. Now what we're going to do is we are going to use the SQL injection vulnerability. And for this application, I do not have any authorization rules at all built into it. I mean, by default, it should not allow me to get access to anything other than an admin account. So I just have the SQL injection vector and now the admin username. What I'm going to do is I'm going to go and dump some messages from the broker. So let's see the queues that we have here. So this is the ActiveMQ which is running on the VM which I have right here. Okay, here it is. It's running right here in this box, and you can see the stack traces which we had a while back. Now I'm going to show you the queues that it has. And this is one queue to which I have already sent 11 messages, which are, okay, the font size. So I'll read the name. It's dump queue 11 messages. So this queue has 11 messages queued ready for delivery. Now the property of the queues is, if there are messages that are queued in it and I read one message out of that, that message must be dropped, right? For the people who are aware of it. And so if I'm an attacker and I read one message out, I would really alert the organization like, whoa, where is my message going? I should have received that. Or, I mean, the messages would start flowing out. So JMS provides a very interesting way of doing things. Like there is something called as queue browser. So what the queue browser does is, you have a queue. It allows you to get a snapshot of that queue, the entire queue at one point of time. So if there is a time t, you get all the messages, a snapshot for that, and you go through those messages locally and dump them down, and no message would be dropped from the queues. So that is a way to get around the protection that the inherent queue property provides. So if the messages are getting dropped, it would alert somebody. But if you're just taking snapshots, writing them down, nobody notices anything, and you're on your own. I mean, you can read messages whenever you want without any alerts going around, even with the message drops or whatever. So I'm going to provide this message property here. So this is a functionality which is called dump destinations. I'm going to provide the queue name, and I'm going to select the destination type is queue because I know it is a queue. And I will say dump me 22 messages, right? We know that the queue has only 11 messages, but I'm saying give me 22 messages. So I'm going to do a start dump. So it read all the messages and dumped it onto my local hard drive. Now, why was it able to read 22 messages? Anybody here? So there are only 11 messages in the queue. Why was it able to read 22 messages? Pardon? Yeah, something on that, yes. So the reason is, when I take a snapshot of the queue, right? I take a snapshot, I write it down. Now, when I go again to take a snapshot, I get the entire snapshot what is present at that point of time. So if I do it 100 times, I'll get those same messages 100 number of times down to my box, if the messages are not running out. So in the queues, this is one problem which you will always face whenever you're trying to do the queue snapshot type of thing. If you are reading them as a queue, taking messages out one by one, you are going to alert somebody. But if you do this way, you may end up reading same message multiple times. So we will see the dumps that is generated here. Okay, so these are the one, and today is 3:30 p.m. and here is the message dump. So these are the messages. So here, this is how you see the messages. The first is the message type, plain message, which I stored. This is just used for signaling. We will go to more interesting things, which is text message. Here is the content of the text message, and it gives you the message type, what the message was, the message content, and all the message properties which are associated with the GMS message. There is message producer ID, connection ID, session ID, and the sequence of the message. Here it will give you the destination, in which it is org, Apache, ActiveMQ command, ActiveMQ queue. So that's a queue type from where we have retrieved these SMS or messages. And then this is the exact name of that destination. And here, what you see is a base 64 encoded, and the base 64 encoded value of the object after serialization. So this is what it would look like. So if you read base 64 decode it, go on reading it, decoding it, you will get the entire same stuff. And then after text message, you have object message. So object message would just be seen as an XML. I'll just show that to you. So here is the XML, and you will have to work on it. I am planning to get, like, the next step would be to have this broken down as an XML. I haven't been able to really get to time to do that. I need to use JDSerialize to basically able to pull content out of it and just add it right here. So the things get interesting when you see map message. So when you write map messages, you say, okay, this is a byte, write it. This is a byte array, write it. This is a boolean, write it into the message. So it will like figure out what content lives in the message based on the type, and it will show you the exact message content as you see here. There was a boolean in the message, there was a float type, there was a byte array, there was a byte, character, and int. It pulled all of that out, segregated it for easier view, and then you can use it as you like. These are also represented as like C arrays or Java arrays, so you can like feed them into your program and do things you want to do with them. And then you have again, it is okay. Yeah, I'll just move ahead. And this is byte messages, so it will dump all the byte array for you. So it will read the byte array from the message, give you all the XML properties, and will show you all the bytes that were a part of the message. So here it is A, B, C, D, E, and F. You can see that 0x41 is for capital A. And that would be it for messages. Yeah, and that's last for is stream. Yeah, and the stream messages, you just write the different objects, like it's boolean, it's integer, it's whatever. So it will just extract all of them one by one and display that to you here. So very interesting if you want to look at things, like just for experimenting with JMS. This tool can help you learn the protocol and the API. Okay, so we saw the demo here. Let's go ahead. So durable subscriber, right? This is very interesting concept, which again JMS API has. So what it allows you to do is, in queues, you can read one message only once. In topic, one message can be sent to everyone, right? So for you to be able to read from a topic, you should be connected to a topic. If you are not connected to a topic or the broadcast station, for as long as you are not connected, you miss the stuff, right? I mean, for example, you are driving on a car, you turn off the radio, you don't get the songs which you should have gotten if you're connected to the radio, right? So this concept of durable subscriber, what it allows you to do is, it allows you to create a temporary storage on the server. So I say, for this topic, create me a durable subscriber. So what the broker will do is, okay, for Narendra, I'm going to create this bucket, I'm going to keep all the messages for Narendra in this bucket until he connects again. So this is a very interesting concept which they thought of to help offline subscription model, right? I mean, if I'm offline, I can create a subscriber, read the messages later on. Now for topics, now if you are connected to a JMS broker for a long time and there is a connection which somebody sees from an organization which should not have connected to the broker in first place, that may raise suspicion. So JMS Digger, what it does is, if you want to read from the topic, it can do that for you. It will connect to a topic, read content. You can keep it connected as long as you want, but you can also create durable subscribers. So you go there, create a durable subscriber, and then you're out. So then the messages will keep accumulating for you. You later go there, connect to it, and retrieve content, and then you're done. So that is what it does. So we will see a small demo. Yeah, I think we have some time. So here you provided the topic name, the message selectors. So this is like a typical string. All right, so let's do this. Let's see the subscribers here. All right, so there is no durable subscriber. There are topics. Yeah. All right. Okay. So I think I'll have to go to my unit test cases and send messages. So I'll just skip it for that moment. I'll just show you how to create durable subscribers so that, I mean, if you know that there is a subscriber, the GMS server out there, you can just go and create subscribers on that. So let's say here we see that there are no subscriber at this point of time. This is empty. I can go and I can say this is the topic to which I want to create subscriber for. So this is the topic name, and won't provide any client name or a subscriber name, and I just do a create. So what it does is it creates a random string, connects to the server, and creates a durable subscriber with that name. If I do a refresh now, you will see a durable subscriber here. Now, all the messages which are sent to this topic from now onwards would be collected for this particular user. Now, there are multiple ways in which we can look at it. Another way to exploit durable subscribers is that I can create a large number of durable subscribers on say the message broker, and it won't discard the messages which are sent to the topic, right? Typically, there are thousands of topics which are hosted on these message brokers, and the messages will keep piling up. That would lead to like hard disk usage, or like the memory usage will go up because it has to cater to a lot of messages which are in memory or written. So that's a way in which you can cause a denial of service, and this tool provides you with an opportunity to create random durable subscribers. So you give it a topic, give it like 50 or 100 number, it will create those many durable subscribers. So it is very hard to figure out what the durable subscriber like somebody has created or you have created. You can provide the client name. So if I say create it for me, it creates 10 durable subscribers for me. You can see we have a lot of durable subscribers. Another feature is that you can delete somebody else's durable subscriber. So to connect to somebody's durable subscriber, you need either two artifacts. One is the client ID, one is the durable subscriber name. So these two are, I mean, I can choose anything I want. There is no mechanism in which anybody can restrict me to connect to any client and durable subscriber name. So if I know a durable client ID, subscriber name, I can basically go there, connect to it, and erase it, which may not be good. I can connect to a topic, that's fine, but I should not be able to delete somebody else's durable subscribers, right? So which I can do with this tool. I can just go, give it the name, and it'll just remove it from the list. So somebody else who comes later says, oh, I need to see what was offline for me. It's all gone. So that's the way you can like cause some more problem for other people. I mean, and then you can do more with JMS API. A lot of times, as I said in the beginning, it's integration between heterogeneous systems. The other system may be C, C++, or whatever, which is typically vulnerable to buffer overflows or other attacks. So you can craft messages such that they overflow somebody's buffer, or you get a shellback from somebody else's client. Let's say two financial organizations are exchanging financial data. But if I'm able to do a buffer overflow on somebody's box in that organization via plain JMS message, how good would that be? I mean, because I know what technology we are using. If I'm also using C++ client, and I know, okay, this is how it's supposed to work, that this is an exploit, and then I can like trigger and control somebody else's desktop with that, or maybe get further ahead than APD type of things can be done. Then you can basically attack the broker, which we saw. You can like create durable subscribers and do other stuff with it, and your imagination is the limit, as always. So these are the references which I went through. So two very good books. One by JMS Mark Richards, and another one is ActiveMQ in Action. JMS specification, which is very good to read, which will provide you the entire format and everything. And ActiveMQ page at Apache, very helpful resources. So if you want to look at JMS security, these things might help. And to conclude, enterprise messaging systems are insecure, and as we see, we can like do a lot of things. This is just started to scratch the surface. There may be things, gems inside as we move ahead. It's important to harden your messaging brokers. Do not think since it's behind the firewall and it's message-oriented middleware, nobody's going to reach to it. Always perform a security audit before deployment, and most important, maintain your guard. Questions, please. Kevin. So the work would range from now getting the copy of those would be first thing, and then like trying to make the protocol, the code to work with those things, because ActiveMQ has a lot of. So far I've worked with two, RabbitMQ a little bit, and mostly with ActiveMQ. So I've tested with these two, and like right now the code is in a state that where I'm able to use it. People may be able to use it with ActiveMQ at this point of time, but to make it work with those, it will be like good to start experimenting with this first, because I haven't done that yet. But the code is pure GMS, most of it, so it should be able to work with the minor tweaks here and there. But yeah, this is something that I still have to test. Yes, sir.
With the work you've done, have you been able to demonstrate who's listening, who shouldn't?
Haven't gone to the other side of the things here. I'm just like trying to see what can I do with a broker and other clients. So when you say listening, what does it really mean?
Historically, with these kinds of technologies, if you had multiple firms involved in a system which was doing this, there would be those oopsie moments where someone would say, just Google it, you'll see it in the past, where someone will say, oh, we turned off some kind of promiscuous broadcast, and suddenly one firm stood up and said, wait a second, that doesn't work anymore? Because they were listening to everyone's traffic, or it just goes back to years. So if you showed a bunch of ways you can own this, but from the perspective of, and then what would you do? The exploits. The most common exploit would be to surreptitiously listen. The second most common exploit would be to surreptitiously listen and delay. And so my question is, or my suggestion is, if you look at creating something that would permit you to go into an environment and say, oh, by the way, here are the people who are listening. There may or may not be adequate logging for you to know that. As you said, it doesn't keep the record off the queue, but hopefully in the best practices, it logs the fact that someone turned on the logging.
Right. So ActiveMQ administration page, which we saw here earlier, it provides you with a facility where you can see who's connected to it. So let's say you go to the connections, and it will provide you with all the connections that are listening, the people who are connected to and listening to this ActiveMQ server. So that's why I came up with the idea of like using Q browsers to get the messages and disconnect, and then using durable subscribers to, I just wanted to minimize the time of connection that I have to do to the message broker so that it doesn't show up here.
Right. Okay.
Good question.
So one of the defenses would be to be able to log in a snapshot, or actually prevent or limit who can do the snapshot.
Certainly. So basically the snapshot, so you have to like make sure that authorization checks are proper so that anybody who has the valid credentials can connect to a particular queue, right? Other than that, if you are providing somebody with access to the queue, they can certainly do a snapshot. Nobody can prevent that because that's inherent in JMS API. That's the part of the specification. So if somebody is able to connect to a queue, they should be able to get a snapshot. Right. Yeah, let's say there are 1 million messages in the queue and I do a snapshot. What type of resources will it consume? As you were mentioning, right? It's going to go, excuse me. Yeah. Right. Yeah, those certainly are like in my plan for research. I plan to do that, provided I'm able to get some evaluation license or whatever. But certainly that is something I'm planning to look at. Here it provides you with a few authentication techniques, ActiveMQ, and I've tested like all three of them so far. And based on that, I've written some functionalities which we can test. Certainly, the more I look at things, the more perspective will be brought in, and I'll try to feed into the tool.
Okay, we have to reconfigure the rooms.
Yeah, thank you for that.